Live. Okay, so what are we learning? What we're talking about is our incenter and our circumcenter. So the objective today, it's 4, 12, 19. Okay. Jacob, can you see that okay?
Yes.
Girls, Renee, can you see that okay? Okay. So, objective. What we want to do is find and use the characteristics. Okay, we're going to find and use the characteristics. Find and use the characteristics of the circumcenter and incenter. Okay, go ahead and write that down. Okay. I always have all these pens, but okay. So, here's what I'm going to do. What is a circumcenter? Okay. So, a circumcenter is the center of a circle. Yeah, we're going to find and use the characteristics of the circumcenter and the incenter, okay? So we found, go back to it, okay? When we did our incenter, okay? Let's see if I can find my construction. Here it is. So when we did our circumcenter, we found it by perpendicular bisectors, okay? And we found it by using the perpendicular bisector of each side, right? And we found was the center of a circle that's on the outside, right? So the circumcenter is the center of a circle circumscribing a triangle. So it's the center of a circle circumscribing a triangle. Okay, circumscribing is outside. So here it is. Here's the center of the circle, and it circumscribes the triangle. Okay, that's what we did. We found the center of the circle that circumscribes, goes around the triangle. Okay, now what we found is it was found by, and it's found by the perpendicular bisectors of each side. Okay.
Can it be used for like other shapes of triangles or just triangles?
No, it can be used for other things, yeah. Yeah, good. Good. We're not going to go there though, okay? Okay, so let's see if that makes sense. Okay, so it's the center of a circle, yeah. That circumscribes a triangle, goes around a triangle, yeah, that makes sense. And it's created by perpendicular bisectors. So my red lines are the perpendicular bisectors. In fact, I probably could put perpendicular here, and I could probably put perpendicular here, okay? Right? So, what it does, though, is it gives us 3 radii that are going to be congruent. That's what we want to look at. So, example 1. Let's do it. Let's graph -2, -2. There's point A. -2, 1, 2, 3, 4. There's B. 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, so I'm going to draw my triangle in, okay? Here's my triangle. Okay, drawing my triangle. How am I doing? Good? So here's my triangle ABC. Everybody have that? I could get my ruler. Out, and I can measure it. I can go 90. But on graph paper, it's really easy. I'm going to do the same thing, but on graph paper, we don't need a ruler. You guys agree? It's graph paper. We don't need a ruler. We can find the midpoint pretty darn easily by just going, okay, well, let's see. The midpoint's got to be, well, from this side, 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, right? So my midpoint's right there. You guys see it? And I want to draw it. Let me turn it upside down so it seems easy for you. I just want to draw it straight up because it's perpendicular, right? I'm going to draw it straight up because it's perpendicular. So I'm just going to go, okay, Draw that straight up. Okay, there it is. There's my perpendicular bisector. It's at 90 degrees, right? And it happens to go through the middle. Okay, so then let's get the easy one. Okay, let's go. I'm going to turn it this way. Okay, so I want the perpendicular bisector of this side. So I got to find the middle. Well, that's easy. Let's find the middle. 1, 2, 3, 4, 5, 6. The middle's got to be right there. Okay, there's my middle, right? And 90 degrees straight up. Okay, straight up, right? 90 degrees straight up. It's easy. Okay. Okay, there it is, right? How am I doing? Okay, turn the page. All right. Now this is a little bit harder to tell, but the middle of this is right there. You guys agree? Middle's right. Turn sideways. The middle's right there, where it intersects, right? And so then if I draw this at 90, so there's my point of intersection. That's my point of intersection, okay? So I did midpoint, perpendicular. I did midpoint, perpendicular, and I did midpoint, perpendicular, okay? Where do they all meet? Right there at that point. That point is the circumcenter. So find the circumcenter. It's at the coordinate 2, 1. So now, if I wanted to, I could draw a triangle, or excuse me, I could draw a circle right around this thing, couldn't I? I mean, I don't have to, but I could. If I can find a compass, I might. Draw this one. Okay. I mean, I could do this, right? I could say, okay, I can probably draw myself a nice circle around this. My circle would go like this, like that, and like that, okay? I don't have to draw, I just had to find it. But there it is. Center of the circle is at 2, 1. Perpendicular bisectors, okay? Thumbs up. Okay. All right, turn the page. All right, now, the incenter. Well, what's the incenter? Well, we did the incenter as well. Let's look at it. So here's my incenter right there. And what it did is it put a circle inside, didn't it? So if I take a look, so how do we find it? So the incenter is the center of a circle inside a triangle. Okay? But it's created by angle bisectors. So it's the center of a circle inside a triangle. But it's created by angle bisectors. Okay? Now, if this is correct, right, if they're really saying this is an incenter, right, then I should be able to put a circle on the inside, okay? Which I'll give it a try, okay? Let me see if I can do that. Can I get that back? Huh?
On the fingers, notice like the triangle takes up exactly half the circle.
Yeah? Say it again.
The triangle takes up half the circle, which is 180 degrees, and the triangle is 180 degrees.
Interesting. That is interesting, isn't it? Yeah, 360 degrees versus 100. So let's see if I can draw it, okay? Let's see if I can draw it, okay? Now let's see if I can draw it in there. Obviously I'm off. Not very good. Now I'm not a very good artist. Oh boy, that's terrible, huh? Oh, it's terrible. Oh well, anyway, you see my terrible. There's my circle. Okay. All right. So K, what do I know? First of all, NK. This is x plus 10. Okay. NL. This is negative 2x plus 1. What do we know about these two segments? Okay, what do we know about these two segments? They have to be equal. You know why they have to be equal? They're radii of the same circle. They have to be equal, right? They have to be. So, can we find the length of MN? Yes. I know this side's got to be equal to this side. which is equal to this side because they're all radius of the same circle. So let's do it. Let's say x plus 10 is equal to a negative 2x plus 1, right?
You bring the 1 over.
Yeah, they have to be equal. So I'll bring the 2x first, though.
Oh, the 2x.
But that wouldn't be wrong. Okay.
I don't know which order it should be in. So
Here,
I'm gonna do it.
always get rid of the smallest x first. Always get rid of the smallest x first. Okay? Right? Minus 10, minus 10. 3x equals negative 9.
Divided by 9.
X equals negative 3. But that is not the answer, is it?
You need to plug,
Got to plug it back in. So I'm going to plug the negative 3 back in. Mn. So I'm going to plug it back in. Let's see, I'll plug it into this one, huh? So I'll go negative 2 times a negative 3 plus 1. Makes a 6 plus 1, which is 7. And since this is 7, this is also 7, and this is also 7. Because all three of them are equal, because they're all the radius of this circle, okay? All right, now, in our journal, we're going to take a look at it again, okay? So I really, really, really want you to get out your journal, okay? I really, really, really do want to get out your journal, okay? So grab your journal.